Welcome to part 1 of our Retopology in Blender class. This first part covers all of the tools that you need to know to be able to do retopology and how to also start the retopology of a head. So how to get set up in Blender so that you can simply go to town and do your retopology. There's quite a lot of information that has to be covered for us to be able to do so, from the basic tools to the plugins that we need to enable to be able to do a retopology, to talking about snapping, relaxation, and other modeling tools that are very useful in the context of retopology. So the first part of this class then is really an overview of all of those essential notions that you need to know to be able to do retopology of anything within Blender. Part 2 of this class will be released shortly afterward and will cover the actual retopology of this head. So taking all of the tools that we will have talked about and creating the retopologized version of our Emily Blunt portrait. If you've seen our other retopology classes that we have on outgang.studio, you've seen that I like to do this approach of first covering all of the tools that are necessary to do retopology first, so that we can get all of that out of the way, and then afterward to concentrate on doing the retopology proper. So in terms of information density then, the first part of this class is the most dense, and it is highly recommended that you take time to digest it properly before you do move on to look at the second part of this class where we will do the actual retopology of this head. Part 2 of this class, if it has not been released already by the time that you are watching, this particular class will be coming shortly in the future. So take the time to watch part 1 of this particular class. Take the time to afterward try out all of the tools that we will have talked about. And once part 2 comes out, then you can watch that to see what is the retopology process for a head. Let's get started. So we're ready to go with the retopology of this particular head. We have our Emily Blunt likeness high poly that is set up here within the middle of the scene. And you can see that I have about 5 million triangles in this particular case. The first thing I want to do is to make sure that the add-ons that we will need for our retopology have all been turned on. So let's go to Edit, let's go to Preferences, and in the Add-on tab, let's make sure that the F2 add-on is turned on. You can see that that is the case here. Let's turn on the Loop Tools add-on. And finally, we need the B Surfaces add-on that is also turned on. Because we have 5 million triangles on this particular head, we may start to get performance issues within Blender's viewport. And if you're having performance issues with your head, then it's a great moment to do a decimation of it. By the way, I have installed a free program called Fraps that shows me what is the frame rate within Blender. And you can see the frame rate at the bottom left of my screen here. So you can see that as I am rotating around, I'm getting a very high frame rate here, around 150 frames per second or so. So I'm really not getting any kind of performance slowdowns myself right now. But you can check this out for yourself, and Fraps is a free software which you can actually get. Here's what the main window of Fraps looks like. So you simply have to look for Fraps on Google, and you'll be able to find a link to download this free software. So if you're getting performance issues within Blender and you're afraid that that will impact your retopology, then it's time to do a decimation. But it's very simple to do so. Decimation is simply the process by which we reduce the amount of polygons that is on an object while retaining the polygons that matter as far as shape and details are concerned. So the process is fairly straightforward. You start by selecting the high poly that you want to decimate. And then afterward, within your modifier stack here within Blender, we're simply going to add a decimate modifier on top of our high poly. And then the most important value that you have at your disposal is this ratio value that is here, which is simply the number of polygons that will be kept after the decimation. So let's go ahead here and set a ratio of 0.1. And take a look at this. We went from about 5 million triangles down to about 500,000. So that's actually pretty good. And we really cannot see all that well any kind of changes to surface definition. The head looks exactly how it looked before. Let's take a look at the wireframe to see what that actually looks like. So the decimation process has collapsed a lot of those polygons that were deemed unnecessary because there were over zones that were relatively flat of the model. And you can see that all of the zones that are very curvy, we have kept a lot more of that definition there. So 500,000 triangles is still way, way above what we actually need to be able to do a proper retopology of this head. So don't be afraid to drop this number even lower if you're still having performance issues after having set your ratio to 0.1. And we can see here how low can we actually go here. So why don't we try a ratio of 0.01 in this case? And take a look at that. So we are down now to only 50,000 triangles. And if we turn off the wireframe in this particular case, we have retained a lot of the sharp lines that we had sculpted, let's say around the lips, around the nose. So decimation is a very, very smart feature that really only gets rid of the polygons in places where they don't contribute to the overall surface definition. So even though we only have 50,000 triangles now, this head would still work very well for retopology. So once again, don't be afraid to drop the number of polygons that you have over your head as low as it needs to until you start to have very good performance within Blender's viewport. And if you are extra concerned about performance, you can even go ahead and apply the modifier afterward. Now, decimation is a very destructive process. So if you do collapse the decimate modifier, make sure that you have saved a backup of your head somewhere, because we do not want to use a decimated head, either for projection later on, once we have finished our retopology, or for baking. Using decimated meshes in those contexts is not ideal, and we want to be doing those processes using the original high poly head. So make sure that you are saving a backup of your high poly head before you have collapsed your decimate modifier so that you can go back to it later on when it is appropriate to do so. We can go ahead and start our retopology. With the high poly that is selected, let's go to Edit, and in here we have our B Surfaces add-on that is there. So with our high poly that is selected, we'll simply click on Initialize. And what this will do is that it will add a new object, as you can see, within the scene. And this particular object will become our low res. Blender has also put us in the annotate mode. So we can actually go ahead here and we can start to draw a few lines over the surface of our high poly. And what I'm going to do here, I'm just going to create a few lines that are crossing each other like that to create a bit of a tic-tac-toe pattern like that. And everywhere where 4 of our lines are crossing, we will have those be converted to a polygon simply by going within our B Surfaces add-on that is here and clicking on Add Surface. As you can see, we now have some nice polygons to start the retopology. A few options that are important to cover at this particular stage. As you can see, our retopology is going through the high poly, so we can't actually really see it properly. That's why you have this little in front option that is right here within your B Surfaces add-on. So go ahead and just turn that on, and it will make it so that you can completely see and easily see the low poly against the high poly there. If you don't like the default color, go ahead and change that. And you can also play with the opacity here of your low poly here. But I find that the default values here actually work pretty well, so we will keep those. As we rotate around, you can see that we can see both the front polygons and we can see the back of the polygons. I'll keep that on for now, but if you are bothered by the fact that you can see the back faces, you can of course go to your viewport shading options that is right here and simply turn on backface calling. As I'm turning on backface calling, you can see that some of the polygons seem to disappear and some of the polygons are still there, and that is because of the annotate tool that have been converted to polygons. Unfortunately, this is a bit of a bug within Blender, but Blender doesn't actually know what is the orientation, or seems to also just simply apply a random orientation to the normals of the polygons. I'm not actually quite sure what's going on there, but this is clearly a bug, as you can see, because all of the polygons should all be pointing in the same direction. So the way that we solve that very easily is simply by adding a edit normal modifier within our stack, and by turning on within the object data properties, the auto smooth option under normals right here. As you can see, this fixes the bug that we had, and now all of our polygons are all pointing in the same direction there. And our normal edit modifier, it's very important that we collapse it at this particular stage. Another option that is important for us to change is the snapping distance, because if we go back within edit mode that is right here, and we grab a vertex and we try to move it around, you'll see that the moment that I move the vertex around and I release it, it's going to automatically snap and merge with another vertex that actually seems to be quite far. There's actually a default snapping distance somewhere that we actually need to change. And this default snapping distance has changed because of the B surfaces add-on. Let's go to the Tool tab then, and you'll see within Options, as I open this here, that we have an option here called Auto Merge, which will make it so that the moment that two vertices are moved close together, they will simply merge together, which is extremely useful when it comes to retopology. But unfortunately, the default value that is here and that is set by that B surfaces add-on, you can see it's set to 1 centimeter by default, which is extremely high in our case here. So 1 centimeter is a really, really large distance when it comes to faces. So we want to take this threshold value and lower that to 0.05. And feel free to play around with this particular value. If you want it to be higher, if you want it to be lower, go ahead and change this value as much as you want. But this will make it so that now we can actually move our vertices and they will only snap together the moment that they are very, very close. Perhaps another wrinkle that is worth for us to talk about at this particular stage will be the offset value here. So I've gone back to our Edit tab, and within our B surfaces add-on here, there is this offset value that is here. If you play with this particular value, it will simply change the value that is set within your shrink wrap modifier. So let's set this to 1 here, and you can see that now my surface is offset by 1 centimeter off of the high poly, and it has been set within our shrink wrap modifier to that particular value. And it turns out that I'm not actually a big fan of keeping any kind of offset within Blender. If you've done retopology in other softwares, you know that it's very useful to keep a little bit of an offset between the low poly and the high poly, because if you don't do that, what actually happens, and if I go ahead here and if I turn off the in-front option that is right here, what actually happens if you don't have a bit of an offset between your low poly and your high poly is that the low poly, because its vertices are snapping directly on the surface of the high res, but because that low res is by definition of a lower density than the high poly, what actually happens is that you start to lose a little bit of volume as we do our retopology. You can kind of tell here as I rotate the camera around that we can see that there's a very slight loss of volume. Now, the amount of volume loss here isn't all that great because the surface here isn't all that curvy to begin with, but we're still experiencing a little bit of that. And that's where that offset value becomes very, very handy. Now for a head, a good offset value would probably be somewhere around 0.05 to 0.1 perhaps. You can see if I just apply that particular value that is right here, so 0.05, you can see that we are largely compensating for that loss of volume. And we perhaps even have a little bit more volume that is added right here. So a value of 0.05 for the offset isn't necessarily a bad value, but I will actually want to keep this offset value to 0 as I do the retopology. And we'll simply worry about this later on, for the simple reason that within Blender, this offset value is a global value applied on the object through the shrink wrap modifier after the fact. So it's actually not possible for me to have, let's say, a different offset value for the polygons that would be around the eyes as compared to the offset value that I would have elsewhere, let's say for the polygons around the skull. If you've done retopology before, you know that it's actually very useful where you have bigger polygons to have a slightly higher offset value, and where you have smaller polygons that are a little bit closer to the surface and that are of a higher density to have a slightly lower offset value. So this is actually a value that is good to play with when you do retopology. And because it is an offset value that is applied after the fact, let's worry about it after the fact and not have to deal with the little bugs and the little issues that will get created earlier on if we have a value that is not set to 0. It's a little bit subtle, okay? You perhaps have to play around with it to kind of see little issues that I'm talking about. But I just found that it's simply a lot simpler to keep this offset value at 0 for now and simply worry about it later. And because we have this little in-front checkbox, it means that we don't have to deal with the visual repercussions of having the low res be snapping directly over the surface of the high res without having any type of offset value. So the way that Blender deals with snapping and offset between the low-res and the high-res is one of the weaknesses of doing retopology with Blender. Now keep in mind, all retopology tools have strengths and weaknesses. But I want to take a few more minutes to really talk about this because I think that there are subtleties here that are important. First of all, you may be wondering at this point, why is it that the low-res even snaps on the high-res to begin with? Yes, we have a shrink wrap modifier that is here, but even if I turn it off, you can see that our low-res is still floating on the surface of the high-res. If I go within edit mode here and I take a vertex and I press G to move it around, you can see that it is still snapping on the surface of the high-res there, even though our shrink wrap modifier is turned off right now. So why is that? When we clicked on Initialize within our B Surfaces add-on, what actually happened is that Blender has automatically turned on snapping here using face projection. And this is the reason why when we move those vertices around, they are still snapping over the surface. So based on that, you may be wondering why there's a need for a shrink wrap modifier to begin with. Well, you see what happens is that even though we have snapping that is turned on and set to face project, not all operations within Blender will respect that. As an example, there is this tool here called Polybuild, which we will explore soon, but I just want to bring it up here for the sake of demonstration. As I activate my Polybuild tool here, and I extrude an edge simply by clicking and dragging here, you can see that those vertices are still snapping on the surface of the high-res. So that's wonderful. But if I use another of Polybuild's features, which is by holding down Control and then bringing my cursor close to a vertex somewhere, and then click and dragging to extrude a face out of that vertex. If you take a look now at the vertex that has been created and has been moved, you can see that that particular vertex is not snapping to the surface of the high-res. So even though we have snapping that is turned on and is set to face project, not all operations within Blender will respect that. And that is why we need that shrink wrap modifier on top of using the face project snapping options. When we turn on our shrink wrap modifier here, if I just click here on the real-time button that has been disabled, this particular vertex now that has been extruded has now snapped to the surface of the high-res. So the shrink wrap modifier really is there to compensate for the fact that to begin with, not all operations within Blender will snap the vertices on the surface of the high poly properly. What happens with the shrink wrap modifier though is that the vertices that have been snapped on the surface of our high poly by the shrink wrap modifier actually exist in a different position in space than the one that is currently visible to us. Even though I can actually select this particular vertex without a problem, the moment that I actually move it here, the moment that I press G here, you're going to see that it's actually going to jump somewhere else on the screen because the actual real position of this vertex is not on the surface of the high-res, but it is actually somewhere off in space. So the moment that I press G to move this particular vertex, it actually snaps to its actual original position. Although in this case here, it is still getting projected again, so it will actually snap somewhere else over the surface of our high poly. Anyway, so that may happen to you, okay? When you do move transform vertices, while you're having that shrink wrap modifier that is applied, some vertices may actually jump around a little bit. Or in another context, you may move two vertices together to get them welded together using that auto merge option, but they won't actually weld because the truth is that one of those vertices is actually much further in the distance than what is actually displayed. So this isn't something that we have to worry all of the time, but it will happen once in a while that you may start to get odd behaviors when you are transforming vertices around. And if that's the case, okay, the best thing that you can actually do is to simply collapse the shrink wrap modifier and reapply it. And we will do this regularly. We will collapse the shrink wrap modifier, we will reapply it, because when we collapse the shrink wrap modifier, we are baking in the position of each of the vertices as they are snapped over the surface of our high poly. So that's exactly what we will do in this particular case. We're simply going to go here, click on this little drop-down arrow that is right here. And actually, let's get out of edit mode first. Let's go back to object mode, and then let's collapse our shrink wrap modifier. And now that particular vertex that was way off in space is now correctly snapped to the surface of our high poly, and it will stay there. So let's reapply manually now the shrink wrap modifier then. Let's go to add modifier. Let's add a shrink wrap here once again. Our wrap method here, let's set it to target normal project. Snap mode here, set it to above surface. And a target, simply select your high poly. Or alternatively, you could duplicate your shrink wrap modifier and apply the first iteration of it. And finally, you have this little option that is right here that is actually very, very useful, this little on cage option, because this will actually allow you to see both the final position of the vertices when they are snapped over the surface and their actual position in space before the shrink wrap has been applied. So for the sake of demonstration here, let me take my poly build tool here once again, hold down Control, click and drag here to extrude a vertex out. And as you can see, because my on cage option here is disabled, I can actually see both the real position in space of my vertex and its final position as it is snapped over the surface of the high poly. Although in this particular case, if I want to select this vertex, I have to move my cursor over its original position, as opposed to how we were before, which was to move our cursor over the final position of the vertex, which is actually what we will keep. For the most part, we will actually keep this on cage option turned on, but feel free to disable it if this is not something that you like. Before we start talking about other modifiers, such as the mirror modifier, just another quick tip about the annotate tool. So let me get out of edit mode in this particular case, and then let's use our annotate tool here once again. And just a little tip about this, okay? You've seen me do lines with the annotate tool that were crossing each other and which had been converted to polygons afterward by clicking on this little add surface button right here within our B surfaces add-on there. But there's actually a second way that you can use those annotations. This second way actually leads to few less visual bugs. We don't have that normal bug. I haven't seen it yet using this other way to use the annotate tool. But because you know now how to solve that particular normal bug where the normals are not always pointing in the proper direction, and you can really use the annotate tool in whichever way that you want. But the other way that you can use these annotations, what we can actually do is instead do a series of parallel lines, which is actually a great way to do something here like start to block out the geometry over the skull here. Because we know that all of the edge loops that we'll have in this particular zone will all be flowing in the same direction. And by simply creating lines that are parallel to each other and not creating lines that are crossing each other, the annotate tool will actually give us a very different result once it is converted into a surface there. So let's go ahead and do that here. Let's click on add surface. And you can see what has actually been created now. We have all of those nice quads, all of those nice edge loops that all have been created. Everywhere within the space between two of those lines, we have polygons that have been added. So this is actually a great way to fill up a surface very quickly here. And at the bottom left of our Blender viewport, you can actually see that we have extra options here for the way that these surfaces or the way that these annotations have been converted into surfaces. This cross option that is here is the number of edge loops that have been added that were crossing through each of those annotations that we had on the surface. And this particular follow here is the number of subdivisions, if you will, that are added in between each of those annotations. So using these particular options that are here and using this other mode, if you will, of the annotate tool, when it is converted to a surface, we can quickly fill up a surface here where we know that the geometry will be relatively flowing in the same direction. So this is a great way to also start your retopology. I find that using the annotate tool in a tic-tac-toe manner works really well when we are doing things like the contour of eyes, the contour of a mouth. But when we want to fill up a lot of geometry over a relatively flat surface, then using only parallel lines using the annotate tool works quite well too. So use whichever way that you like. Of course, sooner or later, you'll want to have a mirror on here in some way, shape, or form. So let's talk about that. Within our B Surfaces add-on, you can actually see here that there is a button here that says Add Mirror and Other Modifiers. This is a very quick way to simply add a mirror on top of your object. But as you can see, it actually has added a whole bunch of other stuff too in the process. So if we look at our modifier stack, then we have our shrink wrap that is still there, although we now have a new shrink wrap that has been added. So let's actually get rid of that. And the other modifiers that we have then is a mirror, a subdivision, and a solidify modifier. The solidify modifier simply adds thickness, so that is the equivalent of a shell in other softwares that you may have seen. In our case here, it's really not all that useful to have a shell over the retopology of a head, so let's just get rid of that. We really don't need that. The subdivision modifier is also something that we don't want because we will not be subdividing this in the end. I mean, technically we will be subdividing this to continue the sculpting of our head and start our details. But in our particular case right now, subdivision is not something that we actually want. If we are doing a retopology so that this head can theoretically be thrown within a video game at some point, it will not be subdivided once it is within the video game there. So we do not want to have a subdivision modifier at this particular stage because it will simply not allow us to see what is the final result of our retopology. We want to be able to analyze what are the zones of the model that need more polygons. And the only way we can actually do that is by looking for the places where the geometry is relatively low res and where we feel that an extra edge loop or two would actually contribute to getting better surface definition. And we will not be able to do these things if we have a subdivision modifier on top of our stack. So please get rid of that. So we're essentially left with only the mirror modifier, which, as you can imagine, you could have added yourself manually speaking through the add modifier button that is right there. And our mirror modifier, as its name implies, makes it so that we really only have to do the retopology on only one side of the face, and the other side of the face gets automatically created. As far as the options are concerned for the mirror modifier, the only one that's really all that important, there perhaps are two options that are really important in this particular case. First is the merge option, because we do want those vertices that are at the center of our mirror to merge together. If I turn it off here, you can see that some of these vertices here go from being merged to being unmerged. So we definitely want to merge the center line of our retopology. So we want to make sure to keep that on, and we can play with the threshold here. If that threshold is too low, is too high, we can actually play around with that. But for now, let's just keep the default value here and let's see how it goes. And the other option that is important then is the bisect option that is right here, because you can see that part of the geometry that was actually further than the symmetry line of the model still exists, even though some of those vertices are getting welded in the middle there. So we want to make sure that we're also turning on bisect here on the x-axis so that any polygons that is crossing over the symmetry line gets cut off. The consequence of all these things is that we may wind up in this particular case here by having a few pentagons or other n-gons appearing around the symmetry line. So that is something that we'll simply have to be careful of when we are doing the retopology to make sure that we are cleaning these up. In this particular case here, the way that I can easily clean that up is simply by taking this vertex and simply moving it so that it is crossing directly over the center line of the model then. And I will be fixing that particular n-gon that we had there. So that is something we'll have to keep in mind, of course, as we do our retopology to make sure that our center line is nice and clean and that we don't wind up having n-gons in that particular zone. Finally, about the mirror modifier, I'm a big fan of putting the mirror modifier on top of the shrink wrap. We have sculpted this head asymmetrically, which means that we want the shrink wrap, of course, to be applied on the left and the right part of the face independently. We do not want to shrink wrap first and then mirror. We want to mirror first and then do the shrink wrap so that our shrink wrap respects the asymmetry that we have built within the face. Now, the consequence of that is that if there are heavy asymmetries within the face somewhere, if we really have done some very, very heavy asymmetry to the face, It's very possible that the edge loops over one side of the face really need to be manually tweaked and manually moved around so that they will be in the correct position, even if we have a shrink wrap modifier. So if that is the case, if we have done some heavy asymmetry over the face, we'll simply have to deal with that later by manually moving around some of the edge loops on one side of the face after we are done. But for now, it is better to simply keep the mirror modifier on and the shrink wrap modifier on and to leave those issues to be fixed later once we have completed most, if not all, of the retopology. Let's now talk about a few of the tools that we will most commonly use in the context of retopology. Let me go within edit mode and let me also turn on backface cull because it's already starting to be a little bit hard to read the surface because of the transparency there. In fact, let me also increase here the opacity of our low res here just a little bit. One of my favorite tools has to be this poly build tool that is right here. This is a very, very good tool to use in the context of retopology, and it's very simple to use as well. So let me just go ahead here and activate it by clicking on it. You can see that my cursor changes to either a blue dot when I am close to a vertex, or to a blue line when I am close to an edge there. If I simply do a click and drag, I will extrude out that particular edge. So it makes it very, very easy to do a bunch of extrusions and to create a bunch of polygons this way. Once an edge has been extruded, I can press R to rotate it if I want to, let's say, bring this particular poly loop that we are creating towards the mouth, let's say. And I can keep doing this here. So this is very, very easy, very quick to add a bunch of polygons. While I'm in poly build, if I move my cursor near a vertex, I will actually be able to click and grab that vertex and move it around, as you can see. But if I hold Control as I am next to a vertex, you can see that I can extrude that vertex out and create a new series of polygons this way. By holding Control and moving my cursor next to an edge, I can also extrude a triangle out of that particular edge. You know now that you can actually simply click and drag somewhere to extrude an edge when you have an edge here that is highlighted in blue. But the default behavior of Blender still works, and that would be the one where you hold down Control and you do a right click somewhere. And that will also extrude an edge. So this is a Blender default behavior. This isn't there because of the poly build, but you can also use this particular way of quickly extruding edges, of course. Simply hold Control when you have an edge that is selected somewhere and do a right click and you will extrude an edge to your cursor. So you have two ways of extruding then. You can either do a left click and drag to extract, and then you can press R to rotate a particular edge around as it is selected. Or you can hold Control, move your cursor somewhere away from a particular edge that is currently selected, not the one that is highlighted in this particular case, but the one that is selected. So if I select this particular edge that is here, let's say, even though my cursor is now highlighting the one that is in blue here, if I hold Control and do a right click, then I will actually extrude the selected edge to the cursor. So those are two different ways that you can quickly extrude edges. One is using the poly build, and the other one is using a native Blender function. But combining these two is extremely powerful. And while we're there, let's simply mention that instead of holding Control and doing a right click, if you hold Control and Shift combined, and then you do a right click, you will also extrude, but you will be extruding without changing the orientation of the original edge that was selected for the extrusion. Anyway, so those are all subtle ways that you can extrude edges within Blender and extrude faces as well. But all of those options are all very powerful and they're all there at your disposal. So the best thing you can do at this stage is to simply try for yourself these different tools, see which one that you prefer to use, And don't be afraid to try the other ways of extruding edges under certain circumstances where you feel that it may be better to do so. You can also erase polygons or vertices using the Polybuild tool. If I hold Shift and I put my cursor over a polygon somewhere or over a vertex somewhere, you can see that it actually switches to red. So we have a red outline that is showing up. And while we are holding down Shift, if we click, do a left button click on one of these polygons or one of these vertices, they will actually disappear and they will be removed. Now, if you're looking at my screen right now, you can see that this is actually not happening. I'm holding on Shift and I'm clicking on one of these polygons and they are not being erased. And the reason for that is actually because of the select tool that we have here. So I'm just going to press W here to cycle. Instead of using the tweak tool, we're going to go with the default select box option that is right here. And now that I have Polybuild, once again, that is selected as my active tool. If I hold down Shift and I click on a polygon, you can see that I am erasing it. And if I hold down Shift and I click on a vertex, I will remove or I will dissolve that particular vertex. Of course, in the process, we are creating polygons that are not quads or triangles. We are at the mercy of creating n-gons in this particular case, so do be careful about that, but sometimes that can be a useful option. The only thing with the Polybuild tool by default is that there isn't a shortcut that is applied to it. If you put your cursor over here, you'll see that it says here Shift 9, but that may or may not work for you. So if I press Shift 9 here, I'm not actually selecting the Polybuild tool. And this is an extremely useful tool. So my recommendation for you is to apply a shortcut to Polybuild. Now, I've actually hunted around the keyboard a little bit to find a few free keys to use in the particular context here, especially for the Polybuild tool. And I found out that the number 5 here, so not numpad 5, but 5 on the standard 5 that you will have on your keyboard there, actually works pretty well for me as a default shortcut for the Polybuild tool. So that's what I'm going to use going forward here. I'm simply going to right-click here on our Polybuild option. I'm going to click on Assign Shortcut, and then I'm going to press 5 on my keyboard to assign the number 5, not the numpad 5, but the number 5 to be the default shortcut here to quickly access the Polybuild tool. Other tools that are very useful to use in the context of retopology. Now, we won't cover all of the tools, okay, because there are a lot of modeling tools within Blender, but we will certainly cover a lot of the other common ones that we will use right now. And so another tool, another great feature that I really love within Blender, and this is something I used to love to use within 3ds Max, and I'm very grateful to see it here as well, is some loop tools that allows us to nicely space out some of the edges that we may have over a surface there. So within edit mode here, let me simply click on a W to go to our select box tool that is right here. And in edge mode, so I am in edit edge mode here, I'm going to select a few edges right here. And then afterward, we will go within edit right here. And you can see that we now have these loop tools that are displayed here. So this is one of those add-ons that we had turned on at the beginning here of our particular class there. And a lot of these functions can be very useful in very specialized context, but the ones that I like the most and that we will use regularly here is the space tool that is right here. So the last one within the loop tools here. So let's go here within space. And this is very, very simple to use, okay? In fact, let me just select another series of edges that is right here. So with all these edges that are selected, we're simply going to click on space here, and you'll see what's going to happen while we do that here. If I do Control Z here, you can see how all of the edges that we have created here, a lot of those edges aren't spaced equally. You know, they're relatively spaced equally, but they're not perfectly spaced equally there. And of course, as we do retopology, it's extremely important that as much as possible that we keep our polygons with a consistent distance, that we keep our edges to be consistently spaced over the surface as much as possible. This is where also a few relax tools will come in handy later on. But for now, this particular space tool within our loop tools is extremely useful because when you have an edge selection here, so we have selected two edge loops that are parallel, all of those edges are unevenly spaced. But the moment that we press space here, you can see that those edges get redistributed to be equally distant from each other. And that's really, really, really cool. So this is a great tool, and we will use this quite a lot. And in fact, Blender has an option that I have never seen before, which is also very useful, which is this influence percentage that is here. If we bring this value down to somewhere, I don't know, around 30% or so, you'll see that as we do our space, our edges get redistributed in a equidistant fashion, but not at 100% influence. I have never seen a particular influence slider like this in other retopology softwares, and I can see this being very, very useful because sometimes we actually want to bring things to be a little bit more equidistant, but not necessarily all of the way there. So I think that this option here is actually very, very, very cool. And then we can also constrain the influence of our spacing here on one of these axes. And this may become useful, probably not in the context of retopology, but in the context of hard surface retopology, or in the context of even sometimes when creating clothes. There are moments where being able to constrain the influence of this spacing tool over a particular axis is actually very, very useful. So we won't really use this today, I don't believe so, but these options can still be useful in certain specialized contexts. So this space tool here under loop tools, very, very useful, and we will rely on this heavily. Since we are speaking about edges in this particular case, other very useful functions that are default to Blender, and these aren't necessarily proper to retopology, but they're always great to know, of course. If we want to select a partial edge loop somewhere, we simply have to select one edge and then hold down Control and click on the target edge that we want to select. And Blender will simply select the shortest path between those two selected edges there. So that's great to do a partial edge loop selection. If we want to do a full edge loop selection, we simply have to hold down Alt and then simply click on an edge to select the full edge loop. If we hold down Alt and double click on an edge, we will select the open border of that edge if there is one to begin with. If we press Ctrl R, we will be in loop cut mode, which will allow us to add an edge loop across an entire poly loop, as you can see. And as I click and drag, I can slide that inserted edge loop as well. After I have slided my particular edge loop somewhere, I can, of course, go within the options that will be displayed to us on the bottom left of Blender. And we can add even more cuts if we want to. And we can play here with the sliding and other options. So very, very useful too, of course. If we want to select an edge ring within Blender, the best way we can do so is to start by selecting our starting edge and then holding down Control to do a select shortest path to our end edge. So let's say this one that is right here. And then within the option at the bottom left that shows up here within pick shortest path, then let's simply turn on face stepping. And by doing so, you can see that we can select a partial edge ring. So with this partial edge ring that is selected, we could then go to edge, go to subdivide edge ring, and we could here put the number of cuts down to 1 if we want to be adding a partial loop cut somewhere. This is actually very useful because sometimes we don't want to add a full loop cut. We actually want to add a partial loop like this, and then we want to perhaps erase some of the polygons on the extremities of that and then redirect that loop somewhere else. So it's actually very useful to sometimes add partial loop cuts. Of course, another way we could have done that would have been to simply delete some of the border polygons where we want to add a cut through a face loop somewhere. And then afterward, press Ctrl R to add one edge loop down the middle of the partial face loop that is left there. That works as well. Another great tool, of course, is the cut tool. So simply by pressing K, we will be in cut mode, which allows us to do these very, very precise cuts through the surface of our low poly somewhere. And then simply press Enter to commit to that. So also very, very useful and will come in quite in handy. If we want to slide an edge along its face loop, we can hold down Alt click on an edge loop somewhere, and then afterward, go to edge here and do edge slide, which allows us to effectively slide this edge along its face loop. If you get tired of always going within these menus here that are over the top here, you can press Ctrl E to bring up the edge menu. You can press Ctrl F to bring up the face menu. And you can press Ctrl V to bring up the vertex menu. If we want to bridge two edges that are disconnected, one of the great ways to do it is to select the two edges that we want to bridge together and then simply press F. And that will fill up the space between those two edges. In fact, it can be used very quickly to bridge the space between a row of open edges. And what I mean by that is that, let's say that I take this particular edge that is here. Let me just extrude it like this. In fact, let me just extrude it twice. And what I'm going to do here really isn't proper topology, but it's just for the sake of demonstration here. Let's say that I extrude a particular face loop like that. So we have two face loops here that are very close to each other. Let me simply move some of these vertices a little bit closer together. In fact, this particular edge here, let's just get rid of it. So we have in this case what is a missing face loop between the face loop here that is at the bottom and a face loop here that is at the top there. A great way to fill the space between those two face loops that we have is to use the F2 add-on that we have enabled at the beginning here. And what this does, okay, when I have one edge that is selected here, so the edge that will be extruded to become the actual face loop that is missing in between those two face loops that is there. With that one edge that is selected, I'm simply going to press F, and that will fill up, as you can see, it will create a polygon that will fill up in between, or that will bridge the two edges that were at the extremity of the edge that I had already selected. And now that it has been done once, I can quickly press F multiple times. And as I am pressing F, you can see that I'm continuously filling in that missing face loop between our top loop and our bottom loop. So that's a great and very fast way to bridge between two face loops like that. Of course, another way I can bridge between those two open edge loops here is by selecting one edge here. So one of the edges here that is on the open border of my mesh, holding down Control to select the shortest path from here until the end of where I want to bridge, holding down Shift to select here one of the edges that is at the bottom, pressing Control and Shift to add to the selection the shortest path between that selected edge and the border here where I want to end my bridge operation. And then afterward, to either click on Bridge here within Loop Tools, or to press Ctrl E to open the Edge menu and then to select Bridge Edge Loops. So there's a lot of different ways that you can bridge in between open edge loops, as you can see. And we will use other tools once in a while that we haven't talked about, because at some point this actually becomes a class on simply the basics of modeling with Blender, and there are quite a lot of tools there, so there's no way we will cover all of them today. But at least these are the most common ones, or the ones that you will probably want to reach out for faster there, that you will be more tempted to reach out for. There is only one more important notion that we need to cover before we can start to do the retopology of this head together, and that is the notion of relaxation. And I don't mean relaxation for you, although that is really important, and it's very good to be relaxed when it comes to retopology. In fact, retopology has a tendency to put people in a relaxed state. You will hear a lot of seniors talk about the fact that they actually quite like to do retopology because they get into, they feel very zen, they get into the zone, so to speak. They really develop this, this state of flow there. So it is certainly a very relaxing thing to do, but it's not that kind of relaxing that I'm talking about in this particular case. The kind of relaxing that I'm talking about is the kind of relaxation that we want to apply on the vertices of our low poly, because as you can see in this particular case, okay, like we've done a lot of operations here, and we have a lot of vertices right now that are all kind of spread out in ways that are very uneven. We have a lot of loops that are zigzagging around, which is really, really bad. And so it's very important as we do retopology to constantly seek to relax the surface so that the vertices that we have get spread out in the most even way possible, and that we wind up having loops that do not travel in zigzags. All of these loops right now are all zigzagging around. Even this one here, if we look at this particular loop that is here, let's say, you can see that here there's a bit of a harsh angle break that's kind of happening here. And then this loop kind of goes down, and here it goes up a little bit, it goes down a little bit once again. So there's all these kind of subtle variations in terms of how this loop is actually traveling around. All of these transverse loops, it's pretty much the same thing. They're all kind of all broken up. They're all unevenly spaced there. So it's very important when we do retopology to really keep things to be spread out in the most even way possible, because that is what will lead to the best deformation in the end. And hence where the notion of relaxation becomes important. There's a few different relaxation tools within Blender. There is this one that is right here within the loop tools, but this one doesn't necessarily constrain the relaxed surface well to our high poly. So I kind of found that sometimes this one isn't all that great as a tool. So I will present to you other tools that you can use perhaps instead. Of course, one of the ways we could be relaxing this surface right now is by simply selecting, let's say, all of these edges that are right here, clicking on space here, and then selecting the transverse loops, and then doing a space on this again. And this will give us something that is relatively uniformly spaced, as you can see. It's not necessarily a bad way to work in certain cases, but it's very click heavy, as you can see. You have to do a lot of clicks to be able to relax this particular surface this way. So in certain cases, using space is a great way to relax the surface. But in other contexts, if we want to relax a really big surface, this tool may not necessarily be the most appropriate one to evenly space out our polygons. So the best tool that we actually have at our disposal is not even a retopology tool per se, but it is one of the sculpting tools. Of course, we've done a lot of sculpting so far on Outgang, so we know at this point how to access the sculpting functions of Blender. One of the great ways actually that we can go from edit mode within sculpt mode, as opposed to try to switch here to the sculpting tab, one of the great ways that I have found out is to simply hold tab and do a gesture towards the bottom like this, as you can see. As I do tab and then a gesture towards the bottom, I am now automatically in sculpt mode. If I want to go back to edit mode, then I have to hold, press tab and then quickly move my cursor towards the right, just like this. And I am back in edit mode, as you can see. So if you do them quickly, hold down tab and then do a gesture towards the bottom, sculpt mode, hold down tab, do a gesture towards the right, edit mode very quickly. That's a great way to switch between these two modes. Now, this may not actually work for you by default though, okay? If this doesn't actually work for you by default, go to edit and then to preferences. And within key map here, simply make sure that you have this particular option that is selected here and that is activated. Pie menu on drag. This is the option that will make it so that if you press tab and then quickly do a gesture towards the right, towards the bottom, towards any other directions, you will switch the mode for that particular object that you have selected. And now that we are within our sculpt mode, then the best tool that we can use to do relaxation is this slide relax tool, which if you are using it will, by simply doing a click, will allow you to actually slide the surface around, as you can see. But this is not what we want to do with this. We don't necessarily want to slide the surface around. Oh, there are cases where that is certainly very useful. But when we have this slide relax brush that is selected, if we hold shift and we do a simple click and drag here over the surface here, you can see that we are actually relaxing. We are smoothing the surface. We are relaxing the surface, but we are doing it in a way where it will stay constrained to the surface. In fact, it doesn't technically stay constrained to the surface. We do have the shrink wrap modifier that is here, of course, so technically it does. But if I turn off the shrink wrap modifier and we do a little bit of this smoothing option, perhaps with our slide relax brush that is selected, you can see that it is respecting the volume that is already there. It's not technically snapping over the surface, but it is respecting the volume that the low res already has, which will make it so that it will always closely match the geometry that is there to begin with and the curvature of the high res there. It's not exact, but it is very close. which means that when we do add our shrink wrap on top of that, any kind of deviation gets accounted for by the shrink wrap. So this slide relax tool is extremely useful. As you can see, we can quickly relax the surface of our object. And it does so in a way that respects the curvature of the low res that is already there. So that combined with the shrink wrap modifier is a great way to quickly relax vertices over a large portion of our mesh. And that covers all of the tools that we want to talk about ahead of starting the retopology proper of this particular head. It's a lot of information I've thrown your way, okay? The best thing you can do at this stage, because we have covered a lot of information, okay? Use those tools. If you do not try to use those tools for yourself, get a feel for how they are, start to develop a little bit of a muscle memory for where those tools are, what kind of shortcuts you have to press on the keyboard to access them. If you don't take the time right now to do that, you will be lost when it comes to starting your own retopology. The best thing you can do is to really just take a break from this particular video, go and try all of those tools out and try to develop a bit of a sense for when they are useful or how you can access them. And that will be very, very useful for you going forward. Part 2 of our retopology with Blender class will be coming very shortly in just a few days. So keep an eye out on the website for that if it has not been posted already. Thanks for watching this class. Good luck with your retopology, and I will see you next time.